Hello students, welcome to your own YouTube channel Study with Ehsan, and I am Ehsan and we're again at your service with a new video. So let's start. Students, as it is clear from the thumbnail of the video that today we are going to discuss a very important topic of class 11 mathematics, that is binomial theorem. Yes, this binomial theorem is a very important topic and you must learn this, because if you are planning to face any of the competitive exam after your 12, then this topic is very important, because most of the questions are given by this topic, and if you are the master of this topic, you can apply the technique in questions which are from other branches and other chapters of mathematics also. So in this video we are going to learn what is binomial theorem, and for your kind information, this binomial theorem for non-negative integers. Yes, non-negative integers, that is the positive integers. And what is this binomial theorem? Let me explain for you. X plus y to the power n, how to expand this expression and using binomial theorem, and this is what we are going to study in this video. X plus y to the power n, where what is n? Non-negative integer. Non-negative integer, that means n is positive integer, not a rational number. Okay, it is not a fraction, it is an integer. And which type of integer? It is a positive integer. Then x plus y to the power n is nc0 x to the power n minus 0 y to the power 0, the first term of the expression, plus nc1 x to the power n minus 1 y to the power 1, plus nc2 x to the power n minus 2 y to the power 2, plus dot dot dot. It will continue up to what? Dot dot dot. And the last term of the expression will be n, you can write here, plus ncn x to the power n minus n, that is it is going to be 0, and y to the power n. This is the last term of the expression. You can see here, this is the binomial theorem for non-negative integers, and x plus y to the power n, when you need to expand this, it is nc0 x to the power n minus 0 y to the power 0, plus nc1 x to the power n minus 1 y to the power 1, plus nc2 x to the power n minus 2 y to the power 2, plus ncn x to the power n minus n y to the power n, and this is the last term. And if you are thinking that it is very hard to memorize, how to memorize this expression, it looks very difficult, then it is not actually difficult. See here, nc0, if you see the number 0, now it is 1, now it is 2, now it is 3, 4, 5, and goes up to n. Okay, and here x power of x, n minus 0, then n minus 1, then n minus 2, then n minus 3, n minus 4, n minus 5, and up to what? N minus n. Similarly, y, powers of y, it is 0, then 1, then 2, then 3, then 4, then 5, and goes up to what? The number n. And what is n? It is this n. Then finally, x plus y to the power n equal to nc0 x to the power n minus 0 y to the power 0, plus nc1 x to the power n minus 1 y to the power 1, plus nc2 x to the power n minus 2 y to the power 2, plus dot dot dot, plus ncn x to the power n minus n y to the power n. Then this is binomial theorem for positive integer. Yes, for positive n. Positive n, this, and which n? This is n. And this is the binomial theorem that we have to discuss and learn in this video. And don't be panic how to solve these, and these are very simple, don't be panic. And the first thing, you have to learn how to find nc0, nc1, nc2, and what actually these are. So first of all, you must know what are factorials. What are factorials? What are factorials? This is the first thing that you must learn. If you are planning to learn, if you are thinking, or if you are going to learn binomial theorem, you must have the knowledge of factorials. What are factorials? See, the symbol of factorials are either this one or this one. For example, and how do we find factorials? In this video, I am going to make you understand completely binomial theorem completely. So it is very necessary for you to know, to understand what are factorials. The two symbols of factorials are this one and this one. For example, if you have to find, and it is written here, find factorial 5, then how will you find? The factorial 5 will be, if this is a question, then your solution will be, your solution starts from here. Factorial 5 will be, start from 5, 4, 3, 2 and 1. Okay, 5, 4, 3, 2, 1. Multiply all the numbers. 5 4 is 20, 23 is 60, 62 is 120, 120 into 1, 120. That means the value of factorial 5 is 120. Factorial n, a general formula for factorial n, you can write here. If factorial n is there, which you need to find, then multiply n by n minus 1, then n minus 2, then n minus 3. You have to decrease the number one by one, dot dot dot, and it goes up to 1. Okay, it goes up to 1. Similarly, factorial 6 will be, start from 6, then 1 less than 6, it is 5, 1 less than 5, 4, 1 less than 4, 3, and it goes up to what number? 1. 6, 5, 4, 3, 2, 1. And when you multiply all these numbers, 6 5s are 30, 34s are 120, 123s are 360, 362s are 720, 720 into 1, it is 720. Now, one thing is clear, how to find factorial of a number. Okay, and this factorial can also be written as, for example, factorial 3. Factorial 3, you need to find, then it starts from 3, then 1 less than 3, it is 2, 1 less than 2, it is 1. You have to go up to 1. Then multiply 3 to the 6, 6 ones are 6. Factorial 3 is 6. Then one thing is clear. I hope that you are now in a position to find the factorial of any of the number. Start from the number, and this you can note as a formula of factorial n. How do you find factorial n? And at this point, I feel it very necessary to mention one very important thing. If you are thinking that what will be the value of factorial 0, then factorial 0 is 1. Yes, factorial 0 is not 0, it is 1. And how it is 1? It is a theorem to prove that factorial 0 is equal to 1 and not equal to 0, and that we will discuss in more detail in the chapter permutations and combinations. But it is not the chapter of permutation and combination, so I don't think that it is necessary to discuss here that factorial 0 is 1. How? Only at this point you have to keep this in your mind, that factorial 0 is 1 and not 0. Okay, and next thing, in the binomial theorem, now you know, find nc0, nc1, nc2, nc3 and so on. So factorials was very important to understand at this point, and now I am going to tell you how to find nc0, nc1, nc2. And first of all, what is NCR? NCR, n objects are there, you are going to select r objects at a time, then C stands for combination. That means combination of n objects taking r at a time. Or let me repeat this, combination of, C stands for combination of n objects taking r at a time. And this is equal to factorial n upon factorial r and factorial n minus r. It is clear? And this was the reason why explaining the theorem, after just writing the theorem, binomial theorem, I explained factorials here. What are factorials? Because you are going to use this factorial in binomial theorem. And I hope the factorial is very clear to you. And NCR, the formula of NCR equal to factorial n upon factorial r into factorial n minus r. And now see some examples on this formula. For example, you have to find the value of 5c2. Okay, then what will be in the place of n? Here it is 5. In the place of r, it is here 2. Then factorial n, that is factorial 5. Compare these two formulas. And factorial r, what is r? It is 2 here. And what is n minus r? That is factorial 5 minus 2. N minus r. N is 5. r is 2. Now, what will be this value? See here, factorial 5 as it is upon factorial 2 and factorial 5 minus 2, it is 3. And if it is no sign there, there is multiplication. Okay, now 5, factorial 5 will be what? Factorial 5 will be 5 into 4 into 3, and you are going to write 3 into 2 into 1, or you can do it, or it is the first time, so let me write up to the last, 3 to 1, 5 4 3 to 1. And you can write below, what can you write here? In the denominator there is factorial 2, then 2 into 1, and again there is factorial 3 also, then 3 into 2 into 1. Clear? And now you can cancel, 3 3 cancel, 2 2 cancel, and what remains? These 2 2s are 4. Then what is 5 into 10? Okay, then 10, this is the value of what? 5C2. You calculated the value of 5C2 here using this formula. Which formula? Using the formula of NCR. NCR factorial n upon factorial r into factorial n minus r. Then 5C2 is factorial 5 upon factorial 2 and factorial 5 minus 2. And now it is 5, 5 minus 2, it is 3, I have factorial 2 as it is, and expanding as per the factorial. Then this is the number. Okay. Factorial 10. And second thing is, let me solve one more example here. Factorial, for example, 6C4, you need to find combination of 6 objects taking 4 at a time. Then factorial 6 upon what? Factorial r and factorial n minus r. Okay. Now it is factorial 6. You can write here factorial 6 upon factorial 4. And what is factorial 6 minus 4? It is factorial 2. Okay. Now you can do one thing here. 6, you are going to break 6. Then 6 into 5 into 4. And if we stop here at 4. Okay. Then factorial 4 below. And also I am not going to expand this. And factorial 2 is 2 into 1. And from here one benefit is there that you can cancel factorial 4 and factorial 4. Then 2 1s are and 2 3s are 6. It is very clear. Now 3 5s are 15. That means 6C4. 6C4 factorial 6 factorial 4 factorial 6 minus 4, like this, and expanding you are getting answer 15. Then 6C4 is 15. Then now it is very clear that how to find factorials. Okay, factorials, how to find factorials.